Good afternoon, all. Yes, good afternoon, Yanshika, Pranshu. Yes, I have received Yanshika. You know. Good afternoon to all. Those who are saying morning, to them also afternoon. Good afternoon, Ravinder sir. So I'm waiting for 1 more minute for the students to join. Then we'll start with these questions 5, 6, and 7, which are left of this exercise 6.4. And this week by Friday or Thursday or Friday, you will get an assignment also based on chapter number 3, 4, and 5, so that you can practice some questions. So guess what are you asking? Test? This is all checked and marks were also told to all. If I have not told or something like this, then you can message me if it is left. Otherwise, report is also sent to school the previous week. Yes, good afternoon. Okay, I'll see Jigyasu, I'll send that. Okay, in the list I'll see. Leave a message on WhatsApp. So it is now 12:05, so too much we have waited for the students. Now all are here. Maximum now D, E, and F are the midpoints of side AB, BC, and CE of triangle ABC. So let us make the triangle ABC. Wait a second. Now there is a triangle ABC where D, E, F are the points. D, E, and F. So there is a triangle ABC with D, E, F are the points as the midpoint of AB, BC, and CA. Find the ratio of the area of triangle DEF and ABC. So we need to find the ratio of the area of DEF and ABC. So joining the lines. Let's make the figure. The second, it is taking too much time. Right? What is given in the question, that ABC is the triangle and DEF are the midpoints. So just write that DEF are midpoints of AB, BC, and CA. So DEF are the midpoints of AB, BC, and CA. To prove, what to prove, we have to find. Just write to find. To find area of triangle DEF upon area of triangle ABC, we need to find the ratio of this. Then proof. Now see this. Before proving DEF, before taking out the area of DEF and ABC, we know that we'll be able to take out the ratios only if the triangles are similar. We'll be able to take out the ratios of these triangles only if the triangles are similar, as per the theorem which we are doing in this exercise. So therefore DEF and ABC need to be proved similar, and DEF and ABC can't be similar without proving them a parallelogram. What to prove a parallelogram? See this. Prove this as a parallelogram. Prove this as a parallelogram. And at last, and then prove this as a parallelogram. So how we can do that? Writing by using midpoint theorem, write that D and F are midpoints of AB and AC. D and F are the midpoint of AB and AC. Therefore, DF is parallel to BC and DF is half of BC. This theorem we have done in 9th grade by midpoint theorem. We can write here by midpoint theorem. DF is parallel to BC and DF is half of BC. And if DF is half of BC, then we can write that DF is equals to BE, because E is midpoint of BC. See, we have proved that DF, the line DF, is half of this line BC, and half of this is BE and EC. You can take any of the side. I have took here DF is equal to BE because E is the midpoint of BC. So half of BC is BE, or half of BC can be EC also. So I have written here BC, BE. And we have to give a reason here that E is the midpoint of BC. Also, write that DF is equals to BE. Okay, and DF is parallel to BE. How DF is parallel to BE? Because DF is parallel to BC. Now we have written here. Look, If DF is parallel to BC, then we can write that DF is parallel to PE. Hence, therefore, we can say that BE FD is a parallelogram. If one pair of opposite side is equal as well as parallel, if one pair of opposite side is equal and parallel, then we can say that it is a parallelogram. The way we have written here, EFD is a parallelogram, we can write similarly. This CEDF and ADEF are parallelograms. There is no need to prove again and again the other. Okay, there is no need to prove them parallelogram again and again. Just write here that similarly CEDF and ADEF are parallelograms. Now all of these are parallelograms. Now we can take those two triangles, DEF and ABC, and prove them similar now. In triangle DEF and triangle ABC, in DEF and ABC, we can write that angle DEF is equal to angle BAC. Look here now. I have taken two triangles, one this DEF and one this full BAC, ABC. Now this angle will be equal to this angle. Why? Opposite angles of a parallelogram. See, this ADEF is a parallelogram, no? So this and this are opposite angles of parallelogram, and also we can say that these two angles are the angles of one angle of DEF, and this A angle is of triangle ABC. So E and A are equal. So same I have written. So on this basis, this and this are equal, opposite angles of parallelogram. Just right here, opposite angles of parallelogram, and which parallelogram? Just mention that parallelogram also, ADEF. And after that, let us take one more angle. This F is equal to B. So angle DFE and ABC are equal. And angle ABC are equal, opposite angles of parallelogram BEFD. Therefore, because of this, by A similarity, we can say that these two triangles are similar. DEF is similar to triangle ABC by AA similarity. And the moment you have proved them similar, then you can find the ratio of the areas of two similar triangles. So since ratio of the areas of two similar triangles is equal to ratio of square of corresponding sides. So I've written this theorem. Based on this, we can write that area of DEF, triangle DEF, upon area of triangle ABC is equals to, no, now which side we should take? I am taking DF and BC. DF of this So DF of this and BC of this. Fine. Now from this, we can write in the next step that area of triangle DEF upon area of triangle ABC is equal to DE and BC. Just see this. Make this equation number 1. Make this equation 1 here. In the starting, we have written this now. In starting, we have written this DF is half of BC. Make this our equation number 1. And we are going to use this equation now. DF is half of BC. Since DF is half of BC, we can say that BC is equal to 2 will go this side, twice of DF. So in place of BC, we will write twice of DF. And here also square will come. Right here also square as per the theorem. And DF cancels out. And this is equal to 1 upon 4. So the answer is 1:4. Right, area of DEF is to area of ABC is 1:4. This is the final answer. Note it down. Moving on to the next question then. Now question number 6. Prove that ratio of the areas of two similar triangles is equal to square of the ratio of their corresponding medians. Ratio of the areas of two similar triangles is equals to square of the ratio of their corresponding medians. So let us make two triangles separately. So A, B, C, P, Q, R be the names of these triangles. Given, prove that ratio of the areas of two similar triangles. Triangles are given similar. Triangle ABC is similar to triangle PQR is equal to square of the ratio of the corresponding median. So let us draw medians on this. One more median this way, this side. Okay, then let A, D and PM be the medians. Right here, AD and PM are medians of triangle ABC and triangle PQR. This is given to prove ratio of the areas of two similar triangles. So these are the two similar triangles ABC and PQR, and their ratio of their area should be equals to square of their corresponding medians. It's AD upon PM whole square. Now after this proving part, no construction, nothing required. Just write directly, since ABC is similar to right triangle ABC. It is given in the question that triangle ABC is similar to triangle PQR. If the triangles are similar, then we can say that all the sides means the corresponding sides are in the same proportion. So AB upon PQ is equal to BC upon QR. Can I write these two? AB upon PQ is equal to BC upon QR. AB upon PQ is equal to BC upon QR. So in place of BC upon QR, I'm writing again AB upon PQ is equal to half of BC upon half of QR. What will be the half of BC? I am taking this BD, and half of QR I am taking QM. And just listen, we can only take this half and half only when something like this as these is the midpoint of BC is given, or M is the midpoint of QR is given, okay, or AD or PM are given as medians. In these, we should have no something given in the question like this, that D is the midpoint of BC, then only we can say that half of BC will be BD. Otherwise, we can't take by ourselves that half of BC will be BD. Okay, half of BC here I am writing BD, and reason being that AD is median on BC. AD is median, or you can write a better line here. Median AD bisects BC. Simple, median bisects the line, no always. So that's why half of BC is BD. And in the same way, half of QR is QM. And for the same reason, median PM bisects QR. And let it be first equation. Okay, now take the triangles. In triangle ABD and PQM. In triangle ABD and triangle PQM. Now see, in ABD and PQM, we can say that angle B and angle Q are equal. Angle B and angle Q are equal since triangle ABC is already given similar to triangle PQR. So by CBSE, we can say that B and Q are equal. As the full triangles are similar, no, that's why B and Q are equal. Now I am just in this triangle. See, I am just taking this triangle, this and this. In these two triangles, I have took B and Q equal. And second thing, I am taking this, which we have proved in equation 1. AB upon PQ is equal to BD upon QM. From first. Say this, AB upon PQ. AB upon PQ is equal to BD upon QM. These are the part of this triangle only. So therefore, we can say that triangle ABD is similar to triangle PQM by SAS similarity. And after that, we can write AB upon PQ is equal to AD upon PM by CPST. What I am trying to prove that AB upon PQ means this corresponding side is equal to the corresponding medians. So AD upon PM. So AB upon PQ is equal to AD upon PM by CPST. Now considering this, the second equation. Now by the same, the area ratio theorem. I am not writing the theorem again here. So by area ratio theorem, it is, we can write that area of triangle ABC upon area of triangle PQR is equals to AB upon PQ whole square. This is by theorem we can write as, see this, ABC and PQR are similar to each other. So we can write that area of ABC upon area of PQR will be equal to AB upon PQ whole square. Fine. So AB upon PQ whole square, but AB upon PQ we have proved already equals to AD upon PM. So in place of AD upon P, AB upon PQ will write AD upon PM whole square. So this is proved, hence proved. Note it down. We have the last question left that we have to complete right now. Now we'll be able to start tomorrow with the new exercise based on Pythagoras theorem, the most important exercise of the chapter. Then question number 7. Something do by yourself also. You okay? Do that by yourself. For any confusion, you can ask. Don't worry. Okay, it's your choice. So question number 7. Prove that the area of an equilateral triangle described on one side of a square is equal to half the area of equilateral triangle described on one of its diagonals. First of all, we need a square. Make a square and make one diagonal of this. So you have to make a square, then you have to make an equilateral triangle on one side. So I have made here an equilateral triangle on one side of a square. So first of all, let me name the square ABCD. ABCD is a square where ADE, I have made an equilateral triangle. It is written here that equilateral triangle described on one side of a square means on one side of a square, any side you can make on any of the side. I have made on AD. I have made this equilateral triangle on AD. Fine. See, sides of squares are equal. So AD, AB, BC, CD all are equal. and sides of equilateral triangle are also equal. So AD, AE, and ED are equal. See, this AD is common of square and equilateral triangle. It means all of these sides are equal to each other. Rest, area of equilateral triangle described on one of its diagonal, and one equilateral triangle we have to make on the diagonal. Okay, I am making one equilateral triangle on diagonal. Wait a second. Okay, then that's where you have to make. So there is a diagonal. On one diagonal we have made an equilateral triangle, and on one side also we are making an equilateral triangle. So these sides are equal. Given triangle ADE and triangle BFD are equilateral triangles. Also ABCD is a square. Solution of this question is very simple. To prove, we have to prove that area of equilateral triangle on which is made on side is half of the area of equilateral triangle which is made on diagonal. So we have to prove that area of ADE, this triangle is made on side of square, is half of area of triangle BDF. So how we can prove that? Proving starts here. As we know that diagonal of square is equals to root 2 multiplied by side. So how to find out the diagonal of square? That is root 2 multiplied by side. What is the diagonal here? BD root 2 into side. See, I know I am taking this diagonal. I am taking this diagonal BD in place of diagonal, and in place of side I am taking this side. Okay, AD. So diagonal of square, which is BD, is equal to root 2 multiplied by side. So I can take no any side of the square, but I am taking this side on which I have made this equilateral triangle. So BD is equal to root 2 AD. Make this your first equation. Now after this, write, I'm writing this side now. Since triangle ADE and triangle BDF are equilateral triangles, yes, no, it is given, they are equilateral, therefore there is no need to prove similarity. We can write that ADE is similar to triangle BDF. Okay, by AAA it will be proved. Simple, because all the angles are of 60 degrees. So ADE and BDF are similar to each other, and therefore by area ratio theorem, we can say that area of ADE upon area of BDF is equals to the square of their corresponding sides. So I am taking side of this ADE, AD, and I am taking side of this BDF, this BD, whole square, as these are the sides of corresponding sides of these two triangles, AD and BD. Now AD and BD relation we have written here, that BD is 2 root 2 AD. So in place of BD we will write root 2 AD from equation 1. And this way same ADE upon area of triangle BDF. Then here AD and AD cancels out, and square of 1 will be 1 and square of root 2 will be 2. So area of triangle ADE upon area of triangle is BDF is equals to 1 upon 2. Now area of triangle ADE will keep this side and bring this BDF that side. Take this. So it is proved here. Area of ADE is half of area of triangle BDF. This only we have to prove. Proving of this is very simple. Only here you have to concentrate that area of square is, sorry, diagonal of square is root 2 multiplied by side. And after that, we can directly apply the theorem and we'll get the answer. Note it down. And with this, today's class will get over. And this week, you will get an assignment on the chapter 3, 4, 5. And based on that, we'll see if there will be any problem or doubts. Then I'll take a doubt session on that assignment and I'll take those doubts, particular questions. Okay. Note it down. And those who have written, they can leave the class now one by one. The lecture is over. Bye. Take care.